Looking at number 1, it says determine the number of and type of roots of each, for each. So we just read that the degree tells you how many roots there are going to be, which is a total amount, not just real roots. Okay, so this degree is 1, so I know it's going to have 1 root, and it also tells us to determine what type it is, meaning how many imaginary, how many real. Okay, so to do that, we're going to solve for x. So that for this one, x is going to equal -3, and that's a real number. So you would just write down 1 real root. Okay, so look at number 2. That's the answer. So on number 2, the degree is 2, so that means you're going to have 2 roots total. So really the question is, are they going to be real, imaginary, what kind are they? So for this one, let's factor, or see if we can factor and solve it. So I'm looking at my constant value, 16, it's positive 16. What 2 factors of positive 16 add to be -8?
4.
Okay, so I can expand that middle term using -4x for the middle number, and then group and factor. So my first 2 terms I can factor an x out. My last 2 terms I can factor out a -4. So what I wind up with is x minus 4 times x minus 4. So I have the same root. It's a double root. If I solve those for x, I'm going to get x equals 4 2 times. So we talked about this a little bit before in other, previous classes. But what that means is here's your root where x is 4. The parabola is going to come down, hit that number, and go back up. So it bounces off of that value for x, and that's what happens when you have a double root. Okay, so for your answer, you could say double real root. So that means 2 real roots. Okay, so let's look at number 3. X to the third plus 2x equals 0. So since the degree is 3, that means I'm going to have a total of 3 roots. And I want to factor. The only way I can factor this is with the GCF, the greatest common factor. They both have a factor of x, so I'm going to take that out. And x squared plus 2. So since I have a squared term and a constant inside the parentheses, I can set that equal to 0 and use the square root property. But that's only when it's a squared term. You can't use the square root property if you have like an x to the third or any other exponent. Okay, so this one's already solved for x. It's equal to 0. For the x squared plus 2, I have to subtract the 2 and then take the square root. So when I take the square root, x is going to equal plus or minus what? I radical 2, that's right. So that gives me 2 imaginary roots, right? Because it's plus or minus. So my description would be 1 real root and 2 imaginary roots. Okay, so you guys do number 4. You have a question?
Yeah.
Okay, so let's look at number 5. Number 5 says, find the number of positive and negative zeros of each. So this is where we're going to count the sign changes. And this is just so you guys know what your graph is going to look like, really. Okay, it's an expectation for you. All right, so first of all, we need to look and see what the degree is. The degree is 5, so I'm going to have 5 roots total, period. That's real numbers, imaginary roots, all of it combined. Okay? So first I'm going to figure out possible positive zeros. How many could I have? Not what they are, but how many positive roots could I have? Okay, so to do that, I want to first make sure that the polynomial is in descending order. So it's going 5, 4, 3, 2, 1 on my exponent. So that's the way it should be in. That's the correct order. If it's skipping an exponent, it doesn't matter. You don't need to worry about it. Okay, just keep it the way that it is. So to figure out your possible positive roots, we're going to leave it in the original form as long as it's in descending order, and then we're just going to count how many times it changes from positive to negative and negative to positive, back and forth. So for example, this first term is a positive x to the 5th. So it goes from positive, the next term is negative. That's one sign change. Okay, then this negative 6, negative 3, that doesn't change signs. It stays negative, so that's a 0. Then I have negative to positive again. That's one sign change. Okay, the positive 7, negative 8, that's one sign change. Negative 8, positive 1, that's a sign change. So all the way across in order, from left to right, I have 4 sign changes. So I could have as many as 4 positive roots. Okay, so that's my top possibility. I will not have more than 4 positive roots. Okay, so then the rule is that I take the biggest number that it could be and decrease it by 2's until I get to either 1 or 0. If this starts out as an odd number, it's going to stop at 1. If it starts out as an even number, it's going to stop at 0. So that means that I could have 4 positive zeros, I could have 2 positive zeros, I could have 0 positive zeros. Okay, so now on the next part, to find my possible negative zeros, I'm going to find f of negative x and count the sign changes again. So I'm going to substitute a negative 1 in for every x, but let me give you a shortcut. Whenever I have an odd exponent, negative 1 to an odd degree is going to stay negative 1, right? It's not going to change to a positive 1. The sign will stay a negative. Is everybody with me? Okay, but if I plug it into an even degree, negative 1 to a 4th power or negative 1 to the 2nd power, then it's going to change, or then it's going to stay the same, right? It's going to be a positive 1. I'm sorry. Yeah, it's going to be positive 1. So what I'm trying to get at is, if it's an even degree, that's not going to change the x, and so it's not going to affect the sign in front. If it's an odd degree, it's going to be a negative 1, so it is going to change the sign in front, because now it's going to be negative 3 times negative 1. Okay, so my first term is x to the 5th power, so that's going to change it to a negative x to the 5th power. So anything to an odd power, the sign is going to be negative. Okay, this next one, x to the 4th power, it's going to turn out to be a positive 1, so the sign is going to stay the same in front. It's going to be a negative 6x to the 4th. An odd power, it's going to be a negative 1, so the sign in front is going to change, because negative 3 times negative 1 is plus. X squared is going to be a positive 1, so the sign in front is not going to change, because you're just multiplying by a positive 1. X to the 1st power, negative 8 times negative x, it's going to be a plus 8x. So every odd degree is going to change, every even degree is not going to change, and the constant always keeps the same sign. So now we're going to go through and count all the sign changes again. This first term is negative, the second term is negative, there's no sign change. It goes from negative to positive, that's one sign change. Positive, positive, that's not a sign change. Positive, positive, that's not a sign change. And your last two, there's no sign change there either. So there's only one through the whole thing for negative x's. So I will have one negative 0, one negative root. It doesn't matter how many positive roots I have, I'm going to have one because I can't subtract 2 and, from that. I can't decrease by 2's. Did you have a question? Okay, so my last step is, it doesn't ask you to find the imaginary zeros, but we're going to find them because they're going to ask for that in the assignment. Okay, so for my first row across, I'm going to be adding the possibilities together, and the degree is 5, so I'm going to have 5 total zeros. So if I have 4 positive and 1 negative, that's 5 already. So could I have any imaginary? No. So I'd have 0 imaginary if I had 4 positive and 1 negative. If I had 2 positive and 1 negative, could I have any imaginary? I could have 2, that's right. And so if you add up the positive, negative, imaginary, that's going to total 5, which is your degree. If I have 0 positive and 1 negative, could I have any imaginary?
4.
I could have 4, that's right. And so that's how you get the chart that you're going to be making on your assignment tomorrow.